This video introduces two novel video conferencing systems called AgoraG and Agora Pro that aim to support tasks and interactions around everyday artifacts like paper. Paper documents, for example, play an important role in mediating interaction. One of the key properties of paper documents is their maneuverability, or as we have called it, their micromobility. Paper is often shifted or moved to encourage participation or invite a response from another. For example, by sliding or rotating a document, you can provide another with better access to that document. From our previous research, it seems that a real-time collaborative technology should support access to the details of documents in the remote environment, the ability to view a number of paper documents and types of documents in the remote domain, multiple forms of access to another's documents, including focused collaborative activities such as shared writing, private work with documents, and semi-public activities where items may be referred to, but their details are not necessarily made public to the other. Easy ways of moving between these different forms of access. Access to the ongoing conduct and orientation of the co-participant. We are currently developing a technology called Agora that is aimed at supporting two participants interacting with a range of paper documents in and around the desk. The system provides participants not only with a view of the other, but with an image of their hands and the objects they are manipulating projected onto the desk. Agora also incorporates two other areas: a shared document area for detailed work on documents by both participants, a semi-public document area where the documents and activities on them are partially visible. The semi-public document area employs a similar configuration to Tang and Miniman's video draw system. Documents and hand gestures on and over the desktop are captured by a video camera above the desk, transmitted to a remote site, and projected onto the remote desktop from beneath. The size of a semi-public document area is 66 centimeters by 49 centimeters, thus the resolution per unit area is relatively low. Thus, it is hard to read smaller than 36-point fonts. Furthermore, since the image is projected from beneath, documents on the local desktop cover the image of documents on the remote desktop.
Okay, so this is library. Can you see my hand?
No.
You can't see my hand? Okay.
In Agora, a shared document monitor and shared document area, similar to those in Ishii's Teamwork Station, support detailed collaboration over and around documents between the two sites. A document camera is positioned right above the shared document area so that it captures documents in this area of the desk. The captured images from two sites are mixed together and displayed on the shared document monitor. Digital video format cameras are used, and as the image is displayed on an LCD monitor, it is possible for participants to read at least 18-point fonts. With the system, participants can engage in activities in and around documents together or individually. Because the system separates the public and semi-public areas, shifts in the participants' orientation marks shifts between individual and collaborative activities. One problem with an earlier version of the Agora system happened when participants pointed to documents displayed on the shared document monitor, even when these were on their own desks. Because of the organization of the cameras, such conduct was not fully visible to the remote person. As supporting this, we are investigating two ways of displaying gestures in the remote space. These are called AgoraG and Agora Pro. In the AgoraG configuration, we used a remote control laser pointer. The laser pointer is controlled so that it points at the real documents in the document area when a remote participant touches the appropriate location on the shared document monitor. As the video image of the projected laser pointer is captured by the document camera, it can be seen on the shared document monitors at both sites. Thus, a local participant can see that the laser pointer is actually pointing at the appropriate location, whilst the remote participant can see a laser spot both on the actual document on the desk and in the shared document monitor. In Agora Pro configuration, we have added a hand gesture camera and a hand gesture projector to Agora. The hand gesture camera captures a local participant's gestures and projects the image down to a real document in a shared document area at a remote site. Since the remote document camera captures projected hand gestures and shows them on the local shared document monitor, a local participant can see that his or her own hand is projected at the remote site. For the remote participant, he or she can see a local participant's hand gestures both on the real document and the shared document monitor. In this way, a participant can point both at a real document in their own space and at a document displayed in a shared document monitor. Over the past few months, we have been conducting experiments with these systems to investigate the ways in which they support remote collaboration. We are especially interested in exploring how the participants can make sense of each other's conduct in relation to the documents. Through these experiments, we hope to clarify how the system might be redesigned to enable participants to configure a coherent environment of action to undertake document-related activity.